So, ideal gas law, guys, we're going to figure out how we can use it to now help us figure out the amount of gas. Okay, if you guys look down here, if we took our combined gas law and we added moles to it, remember, moles helps us figure out the amount of gas. If I add moles to my combined gas law, it looks like this, right? So these look awfully familiar. They look awfully the same. So what we do is we turn this into a constant. Okay, so pressure times volume over temperature times moles. If we fill these variables in at STP, and remember guys, STP means the pressure is 1 atm, the volume is 22.4 liters, the temperature is 273 degrees Kelvin, and moles is 1 mole. If we fill those in, do the math, we get this number here, 0.0821. It's actually 0.08205, but we are going to round it to 1. Okay, this constant allows us to put moles into our equation. Okay, so make sure you guys write down the ideal gas constants and make sure you know that it is that the variables are liters times ATM divided by Kelvin moles. Okay, so today we're going to do some problems using the ideal gas constants and that equation. Okay, as you guys can see, the ideal gas constant can come in many different numerical values. It all depends on the units that you're using. Okay, so we are going to use this one here because our units are liters, ATM, moles, Kelvin. You could also have it with joules, moles, Kelvin, calories, moles, Kelvin, all those different things. But all of ours are going to be 0.0821, right? Remember, we round this to 1. Okay. So here's the equation. Make sure you guys write this down. P stands for pressure. V stands for volume. N stands for amount, right? So that's amount. It could be moles or it could be grams. Okay, we'll talk about that more later. R is your constant, and T is temperature. Okay, so those are the variables we are going to use. Cool. Let's go ahead and jump right in. So I want to figure out what volume, if I have 20 grams of argon, what volume is that going to take up at STP? All right, so I know I'm going to use the ideal gas law. Okay, if I didn't, this right here should tip me off. Okay, anytime I have an amount of gas, so grams, moles, I know I'm going to use PV equals nRT, or PIV nerd, some people call it. Okay, so P, V, and RT. Let's list out our variables and see what we have to solve for. Okay, so I know that the only number they gave me was grams, right? So that is an amount, so that's going to be moles. 20.0 grams of argon. Okay, everything else is at STP. So remember, STP are those assumed values. Okay, I know I want the volume, so I'm going to put a question mark there. Everything else should be STP. So pressure at STP is 1 atm. Temperature at STP is 273. And remember, R is a constant. R is 0.0821 liters ATM over moles Kelvin. Okay, cool. So I'm solving for volume. So let's go ahead and do that. PV equals nRT. I want to isolate volume, get that by itself, right? So I have to get rid of pressure. So pressure is being multiplied, so I'm going to divide by pressure. If I do it to one side, do it to the other side. So my equation should be pressure equals nRT. Oh, excuse me, volume. Volume equals nRT over P. Okay? So let's go ahead and plug in what we know. All right, I'm going to set this up like a conversion line, just like before, okay, just in case I have to convert anything. Just make that a little bit longer. All right, so first thing that I need, guys, is N. So N, I'm just looking over here, is 20 0.0 grams. Okay, I'm going to multiply that by R. R is 0.0821 liters ATM moles Kelvin. Always make sure you guys put the units, okay? T is 273. Okay, that's in Kelvin, so that's good. If it wasn't in Kelvin, I'd have to convert, right? And I'm going to divide that by pressure. My pressure is 1 ATM. Okay. So guys, before I do the math, I want to make sure that everything cancels, right? So it looks like ATM cancels with ATM. Kelvin cancels with Kelvin, okay? But my moles does not cancel because I have grams. So I can convert grams into moles, right? So I got to do a little conversion, set up another conversion box. I want to get rid of grams. So grams of argon is going to go on the bottom right because it's on the top left. And I want to get that to moles of argon, right? So I look up on my periodic table, and I'm running out of room here, but let me just move this to the side. So I look on my periodic table, find argon, and for 1 mole of argon, that weighs 39.948. Okay. So sorry, it's kind of jammed over there, guys, but 1 mole divided by 39.948 grams. Okay. Now my grams of argon cancels with grams of argon. Okay. Moles cancels with moles, and I'm left with liters. All right. So run those numbers. 20 times 0.0821 times 273. Okay, I get 448.266. Divide that by 1 times 39.948. Okay. Divide that, you get 11.22, but let's look at sig figs. Look up at our measurement. I have 3 sig figs for my measurement, so I have to round this to 3. So that's going to be 11.2. What are my units? Well, liters is the only thing not canceled. Okay, that's the ideal gas law, guys. Let's go ahead and do a couple more. All right, so I'm using the ideal gas law, so let's go ahead and set that up. PVNRT. Okay, and it's asking me for pressure. What pressure? So let's put a question mark there. They gave me moles, so moles is 0.00458. Okay, temperature is 25 Celsius, and volume is 19.0 milliliters, right? They didn't give us R. That's okay, because R is a constant, right? R is 0.0821 liters ATM over moles Kelvin. Okay, and guys, you probably caught this already, but they gave me a temperature in Celsius. I need to make sure that's in Kelvin, so I'm going to add 273 to that, right? Cool. If I do that, your temperature becomes 298. So 298. All right, cool. So let's go ahead. Here's our equation. I'm solving for pressure now, right? So we got to get rid of volume. So divide by volume. Your equation should be pressure equals nRT over V. Okay, let's go ahead and solve that. Move this up here out of the way. All right, guys. N is 0.00458. That's moles, right? Remember, keep the units. R is 0.0821. Liters ATM, moles Kelvin. Okay. T is 298. Running out of room here. And volume is 19 milliliters, right? Running out of room. Darn it. Sorry, guys. All right, so guys, let's go ahead and cancel out. Moles cancels with moles. Kelvin cancels with Kelvin, but liters does not cancel with milliliters. All right, so I got to do one more thing, and I ran out of room, so let's just move this down here. Okay, so guys, to convert milliliters into liters, got to do one more step, right? So I want to get rid of milliliters. So put milliliters on the top to cancel with milliliters on the bottom, and I want to get that to liters. Okay, one goes by the prefix. Milli means 10 to the negative 3. So this will allow me to cancel, right? Milliliters cancels with milliliters, liters cancels with liters. I'm left with ATM, which is what I want, okay? All right, run those numbers. Run those numbers, and I get 5.9, or excuse me, 5.897. Okay. Sig figs, however, up here looks like I have 3 sig figs, 3 sig figs, 3 sig figs. So my answer needs to be 3 sig figs. So I'm going to round this to 5.90. Okay. Units are ATM. All right. Last one, guys. I help you set it up, but then you guys run the numbers. Okay. Let's go ahead and set this up. P, V, N, R, T. Looks like I'm looking for grams. So grams, remember, is an amount. So I'm looking for that N. Okay. Pressure is 1.20 atm. Volume is 31.0 liters. And temperature is 87 Celsius. Okay. R 0.0821. Okay. Don't forget, guys, convert Celsius into Kelvin. So that turns into 360. Okay, so let's go ahead and solve. PV equals nRT. What do I want for this? Well, I want moles. So I got to isolate moles. To isolate moles, divide by RT. Do it to both sides. So N is going to equal PV over RT. Cool, cool. Let's go ahead and move this over. All right. Go ahead, run that, guys. See what you get. All right, guys. I got 2.54 grams of H2. Don't forget, you had to convert, because it wants grams, right? You had to convert moles into grams, and it was grams of H2. So that's, in case you got the wrong answer, that is probably what you did incorrectly.